Perfect. So our next speaker has spent over 20 years supporting companies and agencies along their digital transformation journey, covering both strategic, operational, and technical aspects. He is specialized in collaboration and interoperability within and between enterprises, and frequently uses architecture as a way to describe needs and solutions in a structured way. Today, he will present a suggestion for how knowledge and data can be described and stored through a common infrastructure. Please welcome Niklas Häggström.
Thank you very much. I can also say I spent the last 10 years working in air traffic management, so I'm very well aware of the drone problem that we're having and all the regulatory issues that we're having with that. So it's very interesting to hear Tristan's talk about that. Okay, so this is the title of the presentation. Normally when I see this kind of title, I get very skeptic. My trust level is quite low when it comes to, hey, here's this new revolutionary thing that only I have the knowledge of and you don't know nothing about. But the fact is that what I'm about to present, all the technology that we're planning to do and introduce in this architecture is already available. So it's nothing new. We can include AI, we can include blockchain, etc. So all these technologies are already there. But what I'm presenting is a new way of putting these pieces together that allows us to exchange or share information and data in a more efficient way. So what's the problem? The challenge is that today I sit with a piece of information. It could be myself as an individual, or my organization that I belong to. Right? What do I do with this information when I want to share it? I put it in messages and send it to everyone that I want to collaborate with. And these different partners that I have, it could be my suppliers or my business partners, whatever, they take this information and they add their own information to it. Right? Some, they take this information and they split it up and do things with it. Others, they say, hey, you have an eye, I call that a pie. So we're not even talking about the same thing anymore. And some, they send it to others. So the issues are really about this. I don't know where my data is. I have shared this information, but I don't know what happens with it. How is it used? How is it interpreted? When I say car, do they think the same thing? And how do we maintain data consistency? When I change my address, I have no clue how many different partners have my address. So how can I make sure that everyone that needs to have my new address actually has it? And when we talk about trust, what do we base our trust on? It's based on perception. It's based on written laws and contracts. So I can only go to a lawyer and say, hey, or the state and ask, is this the right thing to do with the data? Can I do it? And we're depending on human interpretation. So we need all these lawyers, specifically in the US, right? Where you have to constantly get to agreement on what can I do, what can I not do with the data. And in terms of trust, who should I send my data to? It's based on the perception, so a lot of marketing here. So we take care of your data, of course, it's perfectly safe. But it's also in terms of experience, and some speakers talked about it. I mean, when you lose the trust, it's very hard to gain back because your experience is bad. So these are the kind of things we've thought about in a team, a movement called Origo. So Origo is stemming from the medical sector, where they specifically have tons of these problems. And we thought about how should we address these problems? What are the principles that the solution need to adhere to? And here are the 5 principles that we have defined. The first one is that the knowledge, the concepts that we describe, must be described in a universal way so that both humans and computers can understand it. And this plays very well into the whole area of artificial intelligence and cognitive services, right? We heard about it today. What if we don't know what the AI actually bases its decisions on? It's just a black box. So how can we get around that? It's by making sure that the computers can describe the knowledge in a way that we can interpret, and the other way around. So create a bridge between the AI and ourselves. The other one is that we need to stop copying data and start giving access to it instead. This is the way to manage the consistency. Third principle, if someone uses this data, the owner must always know who's used it and for what purposes. And contracts, agreements, laws, whatever type of consents, they need to be defined and interpreted by machines or in IT systems, as well as in our lawyers' minds. And finally, the last and most important principle is the data must always be stored in a context. So what does that mean? It means that everything that we store, we need to know what is the meaning of the data. What is the definition of the data? Everything we store, we need to know who's the owner. Everything we store, we need to be able to trace who is the user, and we need to know what kind of consents are associated to this data. Sounds like an easy thing to achieve, right? So, what kind of architecture do we need to be able to achieve these things? We have outlined a simple 3-layer architecture, which I've been working on for the last 10 years. So, been trying out different types of versions, and now we're getting into a place where it's really becoming mature, and we think there's a good chance of us being able to actually implement it. It starts with the first layer called Universal Knowledge Description. It contains a set of knowledge description services which has these kind of different components. A meta-ontology. Many of you might not know what a meta-ontology is, but it's a language that allows us to define knowledge in a universally understandable way. If you've been reading up or looking at the semantic web, this is the same type of concept. Okay, so it's a semantic web type foundation on this. It can be read by humans and computers. It supports all languages, all human languages and all computer languages. It has conflict detection. So the idea of these knowledge services is that people all around the world should be able to start defining the knowledge. What do I mean with this type of concept, and what do other people mean? And that will result in us getting a lot of conflicts. So I will say that something is an apple and someone else will say it's a pear. And we need to be able to resolve these conflicts. So we will have built-in mechanisms in this to detect where are the conflicts between the different concepts. Another really important thing is the automatic versioning. So if we want to analyze data and knowledge, we need to know what we knew at the time of the data creation. So 100 years back when we did the T-Ford, we didn't know so much about cars. It was a slightly different concept than we had today. So any type of data from that age, we need to treat in the context of that age period in time. Right? So therefore, all the knowledge is versioned, and we handle versions so we can go back and see how the knowledge has evolved over time. So these are the knowledge definition services. The second layer is a secure and distributed infrastructure. So our idea is that we will create an open infrastructure. So not for any company, not for any state, not for any individual, but for all. It will be able to integrate all our existing systems, so they should be able to talk to the data that is within this infrastructure. It will contain a set of base services that handles authentication and all the security aspects to make sure that this is accessed in the right way. The data will be distributed, right? So we cannot rely on one single central database of big data. It needs to be distributed and controlled by those that own the data. And then we have the last piece there, which is the hosted services. And this is something that's quite new, we think. So imagine that we have all the medical journals of the Swedish population, right? What kind of scientists would want to get their hands on that and analyze that, right? All of them, right? But we have all these privacy issues and data ownership issues that we cannot solve. So we effectively hinder them because we cannot guarantee that they won't misuse this data. So what we can do here is create services that runs within the infrastructure in a secure and trusted environment, which means that they can do analysis on all this data without compromising the personal integrity, for example. So they can see the results of the analysis, but not the actual data that is underlying. While in the infrastructure we will have full traceability, so we will know how the analysis was performed, but that's only for the data owners to decide whether that should be disclosed or not. So that's something kind of interesting. The second thing that is kind of unique to this architecture is this link here between the infrastructure and the knowledge. Today, when we work with standardization, all these standardization bodies, they write papers. They try to standardize the language we should use, what something means, right? It ends up in papers, electronic documents, XML files if you're lucky. But no one has actually taken this and implemented the link to the actual data. So none of the standardization bodies knows whether someone follows the standard or not. You can say, I follow the standard, but in practice, they cannot prove it. So in this architecture, we have introduced this link between the data itself and the context, its definition. So this is something quite new. Then we think about this infrastructure. Who should own that and how should we manage all of that stuff? We think that we need to establish a trusted governing body, which is impartial. It should not be affected by any kind of monetary interests or public interests. So we want to establish a trust that can take care of the property management of the actual infrastructure software. They will take care of any type of changes to the infrastructure, and they will also take care of the certification of infrastructure providers. This means that they will not provide the infrastructure themselves, but they will certify others to do so. So it could be the Swedish government, for example, or a private company that can host this infrastructure. So what do we get from all of this? We have our data. And with this type of architecture, we can achieve better knowledge of the data and transform the data into knowledge in a much more efficient way. We can control it, so we know who is the user of the data, when should I leave it to my doctor, and I can control how long he will have access to the data or not. But at the same time, we will create this availability. So we will make data available that would otherwise not be available to those that would need it. So finding the balance between control and availability is one of the key benefits in this architecture. Please visit our website as well. It's launched just now, so it's still a little bit under construction. But this is the new movement that we're kind of forming this new architecture in. Thank you very much.
Thank you very much, Niklas. You presented a clear picture of a data sharing architecture, but where do you say lies the greatest challenges in realization of this architecture?
It's a good question, of course. So, like I said, the technologies are already there. So we have all the pieces that we need. The trick will be, one, to put them together so they work together. And the second piece will be how to achieve this governance. So we can get the infrastructure to be an unbiased, trusted environment, really, and get all the governance around that. So that will be, I think, the main challenge. So it's basically establishing the trust framework around the governance for the infrastructure.
Okay.
Okay.
Thank you very much.
Right.
Let's give Niklas a big applause.
Thank you.